Okay, hello guys. We're going to try out our first flip video today with notes for section 5.1 covering lines in our chapter with geometry. Today we're going to look at classifying the angles formed when two lines are cut by a transversal, as well as find missing angle measures when two parallel lines are cut by a transversal. First, let's take a look at the vocabulary that we will cover for this lesson. Perpendicular lines are two lines that, when they intersect, form 90-degree or right angles. This is the symbol for perpendicular. It's an upside-down capital T. Parallel lines are two lines that will never cross. This is the symbol for parallel lines. Notice they go up and down. If you were to write them horizontally, it would look like an equal sign. So when you're writing the parallel symbol, it needs to be vertical. A transversal is a line that intersects two or more other lines. Interior angles and exterior angles are formed when a transversal crosses parallel lines. We also are going to discuss alternate interior angles, alternate exterior angles, and corresponding angles in the next examples. When I refer to measuring an angle, I will use the symbol that you see here on the screen. The M in front of the angle symbol indicates that we're talking about the measure of the angle and not just naming it. Okay, let's refer to example number 1 at the bottom of page 372. I would like you to classify angles 1 and 7 as either alternate interior, alternate exterior, or corresponding angles. Take a moment to look at angles 1 and 7 and decide which category it fits into. Angles 1 and 7 are alternate exterior angles. They lie on opposite sides of the transversal and they're both outside. Looking at example number 2, let's classify angles 2 and 6. Angles 2 and 6 are in the same position and they lie on the same side of the transversal. Since angles 2 and 6 are on the same side of the transversal and they're congruent, they are corresponding angles. Okay, next we're going to find missing angle measures. When two parallel lines are cut by a transversal, special angle relationships exist. If you know the measure of one of the angles, you can find the measure of all of the angles. Suppose you know that the measure of angle 1 equals 50 degrees. You can use that to find the measure of angles 2, 3, and 4. Since angles 1 and 4 are supplementary, meaning that they make a 180-degree linear line, we know that 180 degrees minus 50 degrees would be 130 degrees. Angles 1 and 2 are also supplementary because they also form a straight line. As you can see, angles 2 and 3 or angles 3 and 4 would also make a supplementary pair, which would need to make angle 3 50 degrees. You can also see another special relationship called vertical angles. Vertical angles are formed when two lines intersect. They are the angles that are directly across from each other, and they're also congruent. Angles 1 and 3 are vertical angles, both measuring 50 degrees, and angles 2 and 4 are also vertical because they measure 130 degrees both. You could repeat this exact pattern down below into angles 5, 6, 7, and 8. Since angles 1 and 5 are corresponding, they need to be congruent, so angle 5 would also be 50 degrees. Angle 7 is vertical to angle 5, so it's also 50 degrees. And angles 6 and 8 are also going to match angles 2 and 4, being both 130 degrees. Take a second to look at this special relationship. Notice there's only 2 different angle measurements. This will always be true when 2 parallel lines are cut by a transversal. The 2 pairs will have to add up to be 180 degrees. Once you figure out what the 2 numbers are, you can fill in the entire diagram. Okay, let's refer to example 3 on the bottom of page 373. A furniture designer built the bookcase as shown. Line A is parallel to line B. If the measure of angle 2 is 105 degrees, try to find the measure of angle 6 and the measure of angle 3. While figuring this out, justify in your head how you know it. I'll give you a second to try this. Since angle 2 and angle 6 are supplementary, the sum of their measures is 180 degrees. 180 degrees minus 105 degrees equals 75 degrees. So the measure of angle 6 is 75 degrees. Since angle 6 and angle 3 are interior angles that lie on opposite sides of the transversal, they are alternate interior angles. The measures of alternate interior angles are equal or congruent. So the measure of angle 3 equals 75 degrees. Let's try another problem. Mr. Adams installed the gate shown. Line C is parallel to line D. If the measure of angle 4 is 40 degrees, find the measure of angle 6 and the measure of angle 7, making sure to think about how you know this is true. The measure of angle 6 is also 40 degrees, and the measure of angle 7 is 140 degrees. Angles 4 and 6 are alternate interior angles, so they are congruent. Angles 6 and 7 are supplementary. Since angle 6 measures 40 degrees, angle 7 has to measure 140 degrees to total 180. Okay, let's try another example. In the figure, line A is parallel to line B, and line C is perpendicular to line D. The measure of angle 7 is 125 degrees. I want you to try to figure out what the measure of angle 4 is. When you're ready, please start the video again. Okay, the measure of angle 4 is 35 degrees. Let's look at one way to prove that. Since angles 7 and 9 are vertical angles, that means they're congruent. So angle 9 is also going to be 125 degrees. You can notice that angle 9 and angles 5 and 4 together are corresponding since they're on the same side of the transversal and they're the same measure. This means that angles 5 and 4 have to total 125 degrees. If angle 5 is 90 degrees, since it's a right angle, we would take 125 and subtract 90. This leaves us with 35 degrees, which is the measure of angle 4. Okay, that concludes our lesson for our notes on section 5.1, lines. On a separate sheet of paper, I would like you to describe the pairs of congruent angles in a set of parallel lines cut by a transversal. Feel free to look back at your notes to accomplish this and bring it to class with you tomorrow. Have a great night.